once, more than once, or not at all. So in the first question, they're asking name the element that can be used as a fuel. So the first, it can be carbon or hydrogen, can be used as a fuel. In a fuel cell, we use hydrogen, and we can use coal, carbon. Name the element that form an oxide with a similar structure that of diamond. So silicon 4 oxide, that is having a similar tetrahedral structure, same like diamond. Name the element that form amphoteric oxide. The term amphoteric means can react with acid or alkali. So aluminum, that's the right answer. You have to write the name of the element. I'm writing the symbols, but you have to write the name. Name the element that has oxidation of +2 and +3. So basically a transition element. That's iron, Fe. Name the element extracted from bauxite. Bauxite is the ore of aluminium. And the last one, name the element that has atom with electronic structure of 2 and 6. So means total 8 electrons are there. Which element is having, we know oxygen is 8 and 16, so that is O. So you have to write the name of the element, but I was using symbols to answer this question. The next question, iron rusts when it is in contact with oxygen and water. Explain how sacrificial protection prevent the rusting. So in a sacrificial protection, what happens, the more reactive metal tend to lose electron, like more reactive metal than iron, example magnesium, zinc, tend to lose electron easily as compared to that of iron, or it oxidizes instead of iron. That's how it prevents the iron from rusting. So more reactive metal, then iron tend to lose electron easily. React instead of iron, or oxidize instead of iron. Prevent iron from rusting. State one other method of rust prevention. Normally we can use grease to prevent rusting. We can paint the object to prevent rusting. Coating with a grease or oil or paint can also be used to prevent the iron from rusting. Galvanizing. The next question, question 2. Zinc is extracted from an ore containing zinc sulfide. State the name of zinc ore. What we call the ore of a zinc, the natural occurring compound, that's zinc blende. This ore is converted to zinc oxide. Zinc oxide is then reacted with carbon. Write a chemical equation for reaction of zinc oxide with carbon. So we want to remove oxygen from zinc. So the chemical equation in which a zinc oxide reacted with carbon, it will form zinc metal or carbon monoxide, or it can be acceptable carbon dioxide. State what type of chemical change happened to zinc in zinc oxide in this reaction. So what type of chemical change happened to zinc in zinc oxide in this reaction? So when we check the oxidation number, in element state, their oxidation number is 0. So when we write here zinc oxidation number 0. But in zinc oxide, oxygen belongs to group 6, so -2. So zinc should be +2. Overall compound is neutral. So its oxidation state changes, or chemical state changes from +2 to 0. And whenever a decrease in oxidation number or charge, what we call that as reduction happen. And how we define a reduction? It's from oil rig. Reduction is gain of electrons. So you can mention it gain electrons. Explain why aluminum is not extracted by aluminum oxide by heating with coke or carbon. Why we are not using the same technique to extract aluminum, as we have the ore of aluminum, which is Al2O3. Why we are not reacting with carbon? So reason is that because carbon is less reactive than aluminum, or you can mention aluminum is more reactive than carbon, so it cannot displace. Carbon is not able to displace aluminum from its compound. Suggest an alternative method for extraction of zinc from zinc oxide. So one method is written like heating with a coke or carbon. What else we can use? The other method or a technique? So electrolysis, we can also use electrolysis of the molten oxide. Electrolysis of the molten oxide will work for all the, even more reactive or less reactive, it will work for all. With coke or carbon, it will only work for elements which are having a reactivity less than carbon. And simply heating them, roasting is done, like in the absence of oxygen, just heating them alone. That is done only for least reactive metals. Brass is an alloy of a zinc in terms of particle. Why brass is harder than a pure zinc? And it's of 3 marks. So reason why brass is harder than zinc, this is in terms of the size of the particle, because when you have a mixture or alloy, there are particles of different size. So as the particles are of different size, the layers cannot slide over each other, slip over each other, or slide pass over each other. That is why alloys are harder than the pure metal. So alloys are mixture of the metal, contain particles of different size in layers, which cannot slide over each other, or which resist the layers to slide over each other. That is why alloys are relatively harder as compared to a pure metal. Pure metals are malleable or ductile compared to alloys. Aqueous ammonium sulfate. So aqueous ammonium sulfate is warmed with aqueous sodium hydroxide. A pungent smell gas ammonia is produced, and the balance equation for this reaction. So what will be the numbers? When you try to balance, you can start with oxygen followed by hydrogen and at the last other element. So when we try to balance oxygen, as you can see, 4 are there, 4, 5. 4 plus 1, 5, 4 plus 1, 5. Oxygen is balanced. What about hydrogen? 4 multiplied by 2, 8. And we have here 3 and 2. So if I put 2 here, 3 multiplied by 2, 6. 2 and 2. So it will be balanced according to all the elements. 2.8 gram of a sample of impure aluminum sulfate found to contain 0 0.7 grams of impurity. So this is the amount of impurity. Calculate the percentage of ammonium sulfate in the sample. So impure sample contain 0 0.7 grams of impurity. We need ammonium sulfate. So how much ammonium sulfate is there? What will be the mass of ammonium sulfate? Because that is a total mass and that is a mass of impurity. So when you subtract 2.8 minus 0.7, you will get the mass of ammonium sulfate. And then divide by total mass of the sample, which is 2.8, and multiplied by 100. What's the answer for this percentage? It would be 75%. Describe a test for ammonia gas. A damp red litmus will turn blue. So mention damp red litmus. And it will turn blue. Ammonia gas is prepared at the front of lab. A pungent smell of ammonia spread throughout the lab slowly. Name the process that occur when ammonia is spread. So that process we call region of movement of the particle from region of higher concentration to lower. That's called diffusion. Explain using idea about the particle why ammonia gas is spread throughout the lab. So what is the reason? Because it's a gas, so in gas the particles are moving randomly at high speeds. That's why they move from a region of higher concentration to lower concentration. Particles are moving randomly or they have a Brownian motion. That is why they move from region of higher concentration to region of lower concentration. Explain why carbon dioxide gas CO2 will spread throughout the lab at a slower rate than of ammonia. So CO2, the molecular mass is 42, and this one is NH3, which is only 17, because it is having a greater relative molecular mass. So it will have higher molecular mass, so it will move slower. Ammonia is produced in a Haber's process. The equation for reaction is shown. N2 plus 3H2 gives 2NH3. In a Haber's process, the temperature is around 450, the pressure is 200. These values you have to learn, you will find in MCQs. They normally ask these numbers. And using a presence of a finely divided iron, which is as a catalyst, a larger equilibrium yield of ammonia produced if a lower temperature and a higher pressure is used. Explain why a lower temperature and higher pressure are not used here. Why we did not use a lower temperature, sorry. So why we did not use a lower temperature? If temperature is too low, then the particle will move very slow. The rate of the reaction will be slow at a lower temperature. And why we are not using practically very high pressure? High pressure prefer. So why we are not using a high pressure? High pressure because to maintain or to trap the gas at a high pressure, you need a special equipment for this, like the material, the container which can hold a very high pressure. That is why it's difficult to have these apparatus, and that will increase the cost as well. So it will increase the rate, but the question is why high pressure is not used. Explain why a lower temperature and high pressure are not used. High pressure means yield will be higher, rate of reaction will be higher, but why we do not use Like we can use too high pressure, but why we are not using that? Because it will increase the cost of manufacture of ammonia and required greater or special materials for container. State the role of iron in the Haber process. Why we use iron? So it was basically a catalyst. Ammonia is a weak base. What is meant by the term base? So acids are proton donors and bases are proton acceptor. But in exam, if you write hydrogen, then it will be wrong. It should be even not even hydrogen ion. It should be a specific term, proton. Suggest a pH of aqueous ammonia. Aqueous ammonia is a weak base. So what could be a pH of aqueous ammonia? So you can write 12, you can write 11, you can write 10. It's up to you can write 9 as well, but not the range. Write a specific number for that. Don't write the range. Below 12, they all are weak alkalis. Air is a mixture of gases. State the percentage of clean dry air, which is state the percentage of clean dry air, which is oxygen. Give your answer to nearest whole number. So amount of oxygen or the percentage of oxygen in a clean dry air, it's about 21%. The next part, oxygen and nitrogen are useful gases. They can be obtained from air. Name a process. So when we want to obtain gases, we normally first convert them into liquid, and then on the basis of the boiling point, we separate them. This technique is called fractional distillation. State the property of oxygen and nitrogen that allow these gases to be separated using this process. So they have different boiling points. That's why we can use this technique. Carbon dioxide is a covalent molecule. Complete a dot and cross for arrangement. Carbon belongs to group 6. Carbon belongs to group 4. So it will share 4 electron. Oxygen belongs to group 6. So it will share 2 electron. So if this oxygen share 2, carbon will share 2 from that side. And unshared electrons, as oxygen belongs to group 6, so 2 it will share and 4 will be unshared. The 2 mark the distribution. 1 mark is for showing the shared and 1 mark is for showing the lone pair on oxygen. The graph shows the concentration of carbon dioxide in atmosphere over a 60-year period. The measurements are in parts per million. Like if we take a 1 million parts, that is the amount of carbon dioxide molecules. Over the year, you can see it is increasing. The data show in the graph is of global concern. Why this is a global concern? This data, as you can see, the amount of carbon dioxide is increasing. So carbon dioxide is a greenhouse gas. So increase in concentration of carbon dioxide, increase the greenhouse effect, and it will contribute to global warming or climate change. So increase in CO2, or you can first mention CO2 is a greenhouse gas. Increase in concentration of CO2, increase the greenhouse effect. leads to climate change or global warming. Yeah, that's also the pole. The ice caps at the poles will melt and the sea level will rise. That's the climate change you can mention. Name the process in a carbon cycle by which plants remove carbon dioxide from the atmosphere. So, photosynthesis is a process by which carbon dioxide is removed from the atmosphere. Dilute sulfuric acid is electrolyzed using the apparatus as shown. The power supply is there, positive and negative terminal. Basically, what will happen, what is the chemistry of this reaction? We have dilute acid, so it contains hydrogen ion and hydroxide ion, and it contains hydrogen ion and sulfate ion. The hydrogen ions are there which will move towards the cathode, and sulfate, nitrate and carbonate does not move, so hydroxide ion will move there. When hydroxide ion will move there, it will give oxygen and water molecule. So whenever a gas is given off, so you'll see bubbles at anode and bubbles at cathode, and these hydrogen and oxygen, both gases are colorless gases, so you'll see only bubbles. The question is, what is meant by the term electrolysis? The process when we are passing a current through a substance to make a chemical changes, but the distribution of the mark is like passing a current or electricity through an ionic compound in molten or aqueous. So one mark is for mentioning breakdown of a substance by current, and the second mark is either in a molten or aqueous. So breakdown by passing electricity is one mark, and then the second mark is that it should be an ionic compound in molten or aqueous state. And it should be not only compound, you should be specify that ionic compounds by passing electricity, and what should be the state of these ionic compound in either molten or aqueous. Next question, explain why inert electrodes are used. Inert electrodes mean they're not, so they will not react with acid. So it does not react. The term inert means unreactive, so it does not react with acid. Name the product formed at each electrode. At negative electrode, which gas is given off? Hydrogen. And for positive electrode, why we are not writing water as a product here, even though the water is produced, but why we are not writing that as a water? Because already it's a dilute acid, so water is present. That's why we are not writing water. Name the product at each electrode. So when the water is formed, it will remain there. That's why it is not extracted and removed from the cell, electrolytic cell. Write an ionic half equation for reaction at negative electrode. So negative electrode, hydrogen ions will take 2 electrons, which gain electron. That's reduction to change into hydrogen gas. Sulfuric acid is manufactured by using a contact process. This manufacture involves 4 stages. Stage 1 involves the combustion of a sulfur to form sulfur dioxide. Write a chemical equation for stage 1. Sulfur is burned in air to produce sulfur dioxide. The second one, the equation 2, this equation for stage 2 is shown that sulfur dioxide is converted into sulfur dioxide. Explain what is meant by the term equilibrium. So rate of forward equal to rate of backward, that's 1 mark, and no change in concentration and no change in amount, that is a Second mark. No change in amount of the substances or reactant or product. The energy level diagram for a forward reaction is shown. So it shows reactants have high energy, product is having low energy. So it shows that the forward reaction is exothermic. Explain what the diagram show about the energy change in the forward reaction. So what this diagram shows, about the energy change, the reactants have more energy and the product is having less energy. So energy change will be negative or the reaction will be exothermic. So reactants have more energy than product. So energy change will be negative, shows energy released to the surrounding. So forward reaction is exothermic. The next part, stage 3 sulfur trioxide is converted into oleum. Stage 4 oleum reacted to form sulfuric acid. State what oleum react within stage 4. So oleum is basically diluted with water or reacted with water. It's a chemical change. So it's a chemical change. That's why we are able to write the equation for this as well. A sample of sulfuric acid has a concentration of 0.75 mole per decimeter cube. We need gram. So basically moles we have to convert into gram only. So how to convert moles into gram? We have the formula moles equal mass in gram over molar mass. So mass in gram, we need mass in gram, molar mass. Sulfur, hydrogen is 1 multiplied by 2, sulfur is 32, oxygen 16 multiplied by 4, and when we solve this it will come out 73.5 grams per decimeter cube. Question 6. Ethane, propane, butane are all members of homologous series. Name this series. So they belongs to, because the name is ending at ane, so they all are alkanes. State 2 ways member of same homologous series are similar. Not structural formula, general for structural formula. If you write, it means that they all have the same structure. They don't have the same structural formula. They have same general formula and similar same chemical properties. One mole of ethane C2H6 contains 6 exponent 23 molecules. Calculate how many molecules are there in 15 grams. So to get the number of the molecule, the formula, because the moles equal, first we'll get the moles. because 1 mole contain this many. Then we'll use the ratio mole equal mass in gram over molar mass. Mass in gram is 15 divided by molar mass. How to get the molar mass? Carbon is 12 multiplied by 2. So 24 plus hydrogen is 1 multiplied by 6. So that's equal to 30. So 15 divided by 30, that's equal to half. Is it clear? 15 grams divided by molar mass, so we got the moles. And now we'll use the ratio according to the question that 1 mole contains 6 exponent 23, which is also called Avogadro's number. So 1 mole contain this many particles, which is 6 exponent 23 or 6.02 into 10 power 23. 0.5 moles, it will be x. Cross multiply, it will be half of that, so it will be 3.01 into 10 power 23. Propane react with chlorine. Write a formula of the product which does not contain carbon. So there's a substitution reaction, chloropropane plus HCl. So it will form hydrogen chloride or HCl. We have to write a formula, that's why we are writing HCl. If they ask write the name, then hydrogen chloride. Draw the structure of organic product form and show all the bonds, all the atoms and all the bonds. So we have to draw chloropropane. Chloro means 3 carbon. So we have 3 carbon atoms. Chlorine is there and we have to show all the bonds. So there will be hydrogen attached to the carbon. State the name of this type of reaction. What we call this, that's called a substitution reaction. Aqueous bromine is added to ethene. Alkene plus bromine, that's a test for presence, to check the presence of. Look, when it is aqueous, aqueous means bromine water. If it was bromine, it is red to colorless. But if it is aqueous, then it should be orange to colorless. Bromine water, because bromine water means it contains some water and that will reduce the color intensity. Bromine water, practically it is orange in color, not red brown. So you are not supposed to say red brown. Explain in terms of bonding why there is no change, no color change when aqueous bromine is added to ethane. So actually there is no reaction between alkane. There is no double bond. That's why it does not show, or it is a saturated compound. That's why it does not decolorize with bromine, or no reaction with saturated hydrocarbon. That's also correct. There are 2 structural isomers with formula C4. Draw the structure. So what we can do, we can draw one of them as a straight chain and then another one is the branched. It's C4, so this will be CH3, and we have to show all the atoms and all the bonds, so I cannot write next to it. I should show all the bonds and all the atoms. The first one, the name of this one is butane, and the second one is 2-methyl propane. This is 2-methyl propane because this carbon is a branch, that's 1 carbon methyl and 3 carbon in a chain. So it's 2-methyl. One is butane, another one is 2-methyl butane. Butane is formed when longer chain hydrocarbon are cracked. Complete a chemical equation to show the other product when butane is formed. So C4H10 is already there, so remaining is, out of 6 we are left with 2 carbon and 4 hydrogen, so C2H4. A compound contain 85.7% carbon and 14.3% hydrogen. Empirical formula and then the molecular formula. The empirical formula of the compound. So this one is 85.7 and the hydrogen is 14.3. We'll divide this by 12. We'll divide this by 1. So 85.7 divided by 12. What is the answer? 7.14 and 14 point. So 7.14 and 14.3, and then we divide by smallest value. So 7.14 is the smallest, so ratio will be 1:2. So empirical formula is CH2. Then molecular formula we need. Molecular formula is empirical formula times N, and molecular formula is empirical formula times N. And what is N? N is molecular mass, which is 112, divided by empirical mass of CH2. So it will be 12 plus 2, 14. So what is the value of the N here? That's 8. So CH2 multiplied by 8, it will become C8 and H16. The last question. Ethanol can be manufactured by two ways. One is by fermentation, another one is with steam. What advantage of using fermentation? Fermentation, it's use renewable materials, and one disadvantage of using fermentation, so that's a slow process. It will take time to form the alcohol. Then ethanol react with acidified potassium manganate to form water, and the product that turned litmus, so it is oxidized basically to carboxylic acid. State the name of a product that turned, so that which carboxylic acid is there, it will form ethanoic acid. State the type of reaction, that's called oxidation. And part C, ethanol react with methanoic acid to form an ester. So the first name is from alcohol and the second name from carboxylic acid. This will be ethyl ethanoate. And then you have to show all the structure of the ester. So for ethyl ethanoate, C double bond, ethyl methanoate, C double bonded with O. Here 2 carbon and here there is no. So this will be a structure of ethyl methanoate. Then ethanol and sodium chloride, why they have named the type of attractive force in each substance which is responsible for intermolecular forces are there and ionic bond in sodium chloride. So this was October 2020 paper 4 variant 1.